Welcome back students. In this video we are quickly revising our work, energy and power topic. Okay, let's start it. So three major topics we have in this chapter: work, energy and power. Okay, yeah, let's start with work first. Okay, so already you have learned that what is work. Work is done when a force is acting on a body and it displaces that body. Okay, yes. So when how you write it mathematically simply that work done is simply equal to what? Force into displacement, and you write a cos theta here. Why you write this? Because we need always a force in direction of our displacement or opposite to this, that's all. Okay. So here you can write like F dot as cos theta, or you can also write F cos theta into what? Displacement. This way also you can write, right? No problem. Suppose you have a body here and a force, this is a horizontal direction and force is acting like this way F, and this angle is what? Theta, and this body is moving that direction. This is the direction of displacement or velocity. So you take the force component in this direction, that's called of cos theta into what? Displacement, that gives work done in moving this body, right? Okay, this is what scalar format. Okay, so if you write in vector form, then how you write the work done will simply equal to what? F dot s, right? This is your vector form. So always remember that your work done is a scalar quantity, right? Now, yes, you can write in vector form force or force dot what? Displacement, but this is what work is a scalar quantity, right? Work, energy, all are what? Scalar quantities. Okay. Units you already know, I don't need to discuss that what is unit of work and energy, right? Joule, SI system. Okay. Now look here, dimension also you know, nothing to explain here. M power 1, L power 2, T power minus 2. Force into displacement, force dimension is what? M power 1, L power 1, T power minus 2. Multiply with what? Or length dimension, you get what? Dimension of the work. So your work you can write many format. Generally we say two ways. Suppose I say like this is general formula. This we write when the force acting is what? Constant. So how you say that? If force is constant, if force acting is constant, then I will say that work done, you say in this format, you say work done is what? F as cos theta. This is general formula. You can write in vector form also, F dot s. This formula you will use when force is what? Constant. If force is variable, okay. If force is given what? Variable, then you write integration format. Work done will be similar to integration of F dot what? Dx, right? This you can write. If force is given in terms of single variable, suppose they say force is given as 3x square 10x plus 5, this is a force equation given, and they said then find the work done displacing from some coordinate to some distance or other distance, or some value will be given like x1 to what? X2. So we have to find the work done. So F dot dx you can write. This is like single coordinate or single variable, like along x direction only, right? If multiple coordinates are there, then we write this in Cartesian format. Then how we write for multiple? Like in this formula, x also given, y also given, or g also given, all coordinate, right? Then how you write work done? Simply write like this one. You write F force in x direction into what? Dx plus force in what? Y direction into what? Dy plus force in what? Z direction into what? Dz. Like this you find and calculate the total work done. Okay. Yes. Now then we learn how we call work positive and how we call work negative. Correct. So if body is getting displaced in direction of force, right? Body is moving this direction, right? Now in direction of force itself, then work is called positive, means like, or simply properly say like exactly from 0 to what? 90 degree, right? If this angle here is what? 0 to 90 degree, your work is positive, right? Because 0 to 90 means the cos theta becomes what? Positive value. If your angle is what? Here 90 to what? 180, right? Now then you know this term will becomes negative, so work done will be negative. So then simply how you saying that if body is getting displaced in direction of the force, then the work done is what? Positive, or body is getting displaced in opposite direction of the force, then your work is called what? Negative, right? Yes. Okay. So work done we have done. Then look here, there are many units. Okay, when you talk about like SI unit, we write always in joules, right? But if you want to write CGS, you can write ergs, right? And we know that 1 joule is equal to what? 10 power 7 ergs. This we have learned in the first chapter, right? Yes. Okay. Apart from we have many, like we can write in electron volt formula also, that comes in our modern physics or 12th class, not here. So electron volt we can write 1 electron volt is what? 1.6 into 10 power minus 19 what? Joule. That's all. Okay. Like that. Okay. Okay. Once you do work, then you talk about what? Kinetic energy topic. You comes to what? Energy, right now? Yes. So energy we talk. Energy, we talk three energies in this chapter: the kinetic energy, the potential energy, and what? Spring energy. Energy stored in a spring energy, right? Yes. Okay, first you talk about what kinetic energy, right? In kinetic energy, what you learn, you know, general formula is everybody knows what half mv square, right? Yes, correct. Now what happens? This is the kinetic energy. Then we will talk main relation between what work and kinetic energy. This is called what work energy theorem, correct? This is the main thing we have here. So look here, we write here work energy theorem. Then in work energy theorem, what we learn actually, we learn that the work done by a body is simply equal to what change in what kinetic energy. Kinetic energy final half mv square final minus half mv square initial, that gives the work done by that body simply, right? Change in kinetic energy gives what work done, right? Okay, so mainly we write when they ask questions on this, we have to write this theorem mainly. So you can write the combine like this way, the work done is equal to what f dot dx, force into displacement, if it's a variable or it's a constant doesn't matter, and you can also write what half mv square final minus half mv square V2 or V1, you can write like initial and final, okay? Yes, here this is called final, this is called initial, doesn't matter. So this is the complete set which will give answer of all questions actually based on work energy theorem. Work is equal to force into displacement, work is equal to what change in kinetic energy. So sometimes force they are known and this energy changing that we know, sometimes force and displacement know, we have to calculate final or initial energy or velocity. So this relation we can use to answer any questions based on work energy theorem, okay? So kinetic energy is quite simple, this relation mainly we have to use. Now when we move to the potential energy, okay, yes, potential energy, okay. So main relation of potential energy is what, the force is given in terms of potential energy is what, minus du by dx, correct na? When you divide, okay, it's a very basic in physics that something you divide by what time, that's called what, rate, correct na? Rate. And something you divide by what, distance displacement, that's called what, gradient, okay, rate and gradient. Like I said that you divide velocity by time, dv by dt, correct? This is called rate of change of velocity, rate of change of velocity, something dividing by time, that becomes what, acceleration, right? Same way something you divide by distance, that's called what, gradient. So like energy by distance, this is called what, potential energy gradient or energy gradient. So energy gradient simply gives what, force acting on that body. So force is equal to what, minus du by dx, okay. So or for you can write opposite, that energy will be simply equal to what, minus integration of f into what dx, this way also you can say, right now. So same way I was already said that work done is equal to simply what, force and displacement, same thing we are writing work done is what, force and displacement, and work done is also equal to what, change in energy, right now we are writing change in energy, same thing here. This change can be potential, kinetic, or depends on situation what energy is changing, okay. Yes, this is the main thing, okay. Now what happens here, the main question they ask about potential energy is what, equilibrium, because potential energy tell you the equilibrium of the systems, right now. So when you hear the equilibrium word, look here, equilibrium. Equilibrium is what, the net force acting on that system is what, 0. You say net acceleration is what, 0, or net force on the system is what, 0. So what you do, if you want to find equilibrium, then what you do, you write net force is equal to what, 0. So generally in this chapter here we answer this question in terms of potential energy. So what happened to us, always they give the potential energy equation to you, some equations give like 3x square plus 10x minus 5, some energy equations will be given to you, correct. Then they will ask you that find the distance under equilibrium, okay, and tell whether the energy at that time is maximum, minimum or 0. So when we talk equilibrium, whenever you hear equilibrium word means directly net force is equal to what, 0, correct. So what you do, energy will be given, you differentiate that energy term and equal to 0 because force is equal to simply du by dx, okay. So first term what you do to find equilibrium, what you will do, you write du by dx is equal to what, 0. Potential energy equations will be given to you, you differentiate and equate to what, 0, you will get the condition, what you will get here, you will get your x, that under what condition the system will be under equilibrium. So from the first differentiation equate to 0, you will get what, the distance, okay, under which the system will be what, equilibrium. Now equilibrium we have three type, you know, okay. First type of equilibrium is called what, stable equilibrium. In stable equilibrium the potential energy is what, minimum, it happens what, minimum, like in maths I told you maxima and minima, okay. So what happens, if you want to check some minimum value, then what you need to do, okay, first you differentiate and equal to 0, first condition is what, du by dx you write and equate to what, 0, you will get a condition, you will get this condition that at this distance the system will be in equilibrium, but equilibrium again can be three types, stable, unstable and what, neutral. correct? Then how to know when is stable, unstable or neutral? So what you do, you double differentiate it, you double differentiate the same energy equation, then what you will get, if your answer is, look here, this answer is what, greater than what, 0. If your final double differentiation answer is what, greater than 0, sorry, then means positive answer is greater than 0 you say, then this is called what, your stable equilibrium. Under that the energy will be minimum. So if you want to find minimum of anything, minimum value of anything, what you do, you double differentiate and see the answer. If answer is coming more than 0, then that's called what, minimum value. Or you want to know unstable equilibrium, whether it's, then what you do, in this case u will be what, maximum actually, okay, yes. So what you do, again this condition remains same everywhere, any equilibrium differentiation should be equal to 0, you will get x. Then whether it's maximum or minimum, that you will know from this term, you double differentiate, and if your answer comes less than 0, it means that system is what, in unstable equilibrium, and that potential energy will be what, your maximum, okay, yes. Or neutral equilibrium we talk, then neutral equilibrium what happens, the u, I should write like here, the u should be what, minimum here, potential here I should write like u should be what, maximum, and here u becomes what, 0. So what happens in this case, again to differentiate du dx is equal to 0, you will get condition here, then whether it's neutral equilibrium will be told by this term, du by dx square is equal to what, 0. These are three type of what, equilibrium, stable, unstable and what, neutral. Once more, when I say just equilibrium word means net force should be equal to 0, so differentiation of potential energy is equal to what, 0. So this much gives what, the condition at which the system will be in equilibrium, this much only. Now we want to know the what type of equilibrium is this, stable, unstable or what, neutral. For that you have to double differentiate this, then we will note the three conditions, whether this double differentiation answer is more than 0, less than 0 means negative, or equal to 0, we will tell is stable, unstable or neutral, what type of equilibrium is this, right? Okay. Okay, once you do this potential energy, then you move to our next topic, that's called your this one. Okay, when they ask questions on this work done is equal to change in kinetic energy or change in potential energy, always what happen, two type of questions you will see. Measure, you see what, two type of question, one for point masses, one for some regular bodies, okay, continuous bodies or regular body, right? Point masses means what? For example, I say that I want to take the water out of a well, right? Bucket is there, something is gonna, I want to just take it what, out, right? Then this mass which we are taking like m is just like point mass with respect to what, your whole well, correct? So here you want to do work, you are doing work against what, gravity, simply say what, change in energy means what, mgh. At this point energy is what, the depth of this well is 4h. So energy at initial is what, mgh, and final is what, 0, because you are taking what at this point. So change also becomes mgh only, right? That's what simply your work done. This is called a point mass. But in some cases, like I say that the road was there, like some block or rod was there, like you place like this way, okay, and this is a length L and mass m, you want to make it vertical like this one, you want to put in this position, how much work we have to do, correct? So this is not a point mass, a regular body. So whenever you have regular body, this mass varies at every point there is mass from here to here. When you make it vertical, you know, mass is at this point, everywhere there is mass, but in this case the mass is at only one point, right? So we call this as point mass, okay. But this will be a regular body. In this case you are doing work, so you have to talk always about what, center of the mass. Suppose center of mass means this point, right, middle point for a regular uniform body, right? So when you are doing work, like here also doing work against what, gravity. So what happens, change in height happening, this means change in potential energy happening. So what you will talk always about center of the mass, that how much center of mass is shifted. At this point is placed on ground, then is shifted toward this point, so that height is what, L by 2. L is the, suppose the length of this block, right now. So when write energy, you write simply mg L by 2, that's energy change, right? Initially say 0, then final will be this much, so this much will be your work done itself, correct? Yes. So many examples like this I gave, what are the point masses and what are the regular bodies, please see the notes, okay? Yes. Okay, once you do all this potential energy, then you move toward your next topic, that's called your spring energy, right now, spring energy. So energy stored in spring, that's called your spring energy. So when you talk about springs, two things you should know. First thing is that what is spring force, restoring force acting in spring, that's called what, K into what x, okay, that's spring force, we all know. Then what is energy stored in spring is what, half kx square, that's a general formula, right? So this you can call energy stored in spring, or work done in compressing a spring or expanding a spring by some amount what, x, that becomes simply what, half k into what, x square, right? Okay, here two important words they will say. They ask compression or expansion, and two words they will use always. What word? Either they say that calculate the maximum compression, or they said compression under what? Equilibrium. These two words they will say in every equation, okay? Maximum compression or expansion they will say, or they said compression expansion under what? Equilibrium. When this maximum, always use what? Energy concept, means conservation of energy principle you will write. Some ball is coming hitting a spring got compressed, the ball has what? Kinetic energy half mv square, that converted to what? Spring energy half kx square. So you write what? Energy equations you write always, okay? But when they ask that compression under what? Equilibrium condition, then you write always what? Force concept here, right? Force equation here, right? Some force is applied, that converted to what? Spring force kx, right? Yes. For example, like here, how we talk these two. So compression expansion, they are asking two type of questions are possible. Either say maximum compression, you have to write energy concept, and if they ask compression under equilibrium, means you have to write what? Your force concept. Is that clear? Okay. Now for example, suppose I say that this is a vertical spring, I have placed it here and I drop a mass from some height h, this mass m, right now. Then I ask these two questions, that what is the compression under equilibrium, what is maximum compression. Suppose you talk under equilibrium first, okay. This ball is dropped on this, it will oscillate for some time, then after some time it will stop. So it will compress by some amount x and stop. So equilibrium we are talking, then net force will be 0. So we write force equation. So force due to this ball is what? Mg downward is equal to what? Force in spring is what? Kx. Or you write mg minus kx is equal to what? 0. So this x you can find now. But same question I ask you, that what is the maximum compression when you drop from height h? Maximum means you write energy concept. So at this point, suppose you take reference, potential is at 0, then potential, this spring will go up to what? That much, means x is the compression spring. So what is the change in height? Your h plus x also. That's a total change in the height of that object, right now. So change in potential energy will be what? Mg h plus x. That's the change in potential energy. It goes to what? Half k into what? X square. So this way you will get your compression under what? When they ask maximum compression, you have to write energy concept. Same way, suppose horizontal spring is there, then they will talk like about, they can say that a ball is coming with some what? Velocity and mass m. They say what is maximum compression, you can write half kx square is equal to what? Half mv square, right? Same way, if they are talking like about equilibrium, then they will give acceleration of the body, okay? Instead of velocity they will give acceleration, then you can write again like kx is equal to what? Ma. The ball has what? Ma force, and this goes to what? In compressing your spring, right? Yes, this. So two things are there, maximum compression is energy concept, and compression under equilibrium is what? Your force constant, right? Okay. Once you, okay, in spring what else you do? You do some other problems are there like this. Suppose they say that a spring is there, is already extended by x amount, and you want to go further to x2 amount. How much work is done? One spring I have already compressed or expanded. Say, let's talk expansion. One spring is already expanded by what? 5 centimeter. You want to expand further 5 centimeter. Look at the words further. One spring was already compressed by 5 centimeter. You want to go further 5 centimeter. How much work will be done? So from 0 to 5 already done. Then from 0 to here you want to reach, means you want to reach till 10 centimeter, right now. Already compressed by 5 centimeter. You want to go further 5 centimeter. You want to compress it by further 5 centimeter. So you want to do what is work done from here to here. So we calculate work done from 0 to 5, then 0 to what? 10, and subtract them. So how answer come in this case? You write half like k. You write at 10 square minus what? 5 square. That will be your work done. Half kx square. You calculating what is work done, already compressed by 5 centimeter, or say x1 centimeter. You want to go further 5 centimeter, means 0 to 5 to 0 to 10. So we want to calculate work done from here to here. So we calculate 0 to here and 0 to what? Last. Then we subtract them, right? Yes. Okay. Apart from this, the last topic you have learned is what? Your power, right now? Yes. Power is direct questions they ask, always direct questions only, nothing, no confusion at all. Power is what? First you say what? Work by time. You can say change in energy by time. This is a general formula. Or you can also say what? Force into what? Velocity. Correct? Power is equal to what? Rate of doing work or rate of change of energy is called what? Your power, right? And force into velocity, that also becomes power, right? These are the general formulas we use. For everything we can write, like somewhere kinetic energy is changing, you can write change in kinetic energy by time, that gives what? Power required. Okay, work is done, then work done by time is equal to that, also give what? Power. Okay, when you write these formulas, okay, again I am saying like this, this you can write for like a variable, this are I am writing for like constant, okay, it's constant. If it's a variable, then power you can like write dw by dt, rate of change of work, differentiation coming, right now. Yes, so this way also you can write if what? Work is what? Variable, right? Okay, work constant, then you can write this equation. Similarly, force constant, you can write this equation, right? Okay, now Look here, here also get two cases, force is variable or force constant. Force constant with this one, force variable, then again you have to do what, integration, right? Now look here, this formulas you write for a pipe, liquid flowing through a pipe, the same power formula which is very important. So we write in terms of fluid mechanics, okay, the general formula that power required to flow some liquid through a pipe is, we write like mu into what, V cube, where mu is called what, mass per unit length, m by L. This mu is nothing but what, m by L, mass per unit length, okay, how much mass is flowing per unit length of that pipe. So mu into what, V cube. Then you can write this in many format actually, like you write in terms of rate of flow, in terms of pressure. So this also you can write like in terms of this. How you can write? You can write pressure into what, rate of flow. P is called pressure, dV by dt is called what, rate of flow. Or you can also write pressure, you can write in terms of like height of some liquid column, also you can write like rho gh, because pressure is what, rho gh into what, dV by dt. dV by dt is called rate of flow, correct? And when we come to our fluid mechanics, we see that this rate of flow is simply area into what, velocity. This rate of flow dV by dt is nothing but, dV by dt is nothing but what, area into what, velocity, area of cross section into velocity of the pipe, right, liquid flowing through pipe. So same formula you can also write like rho gh into what, a into v, this format also you can write, right? Here, so many format you can write, but here this is like power required to flow a liquid through a pipe, right? Say one more question they ask here is what, how much kinetic energy we have to give. So they ask the rate of kinetic energy imparted, right? Now, at what rate we have to give kinetic energy to make a liquid flow. So that answer comes half of all these numbers simply, okay, half of like mu into v cube, right, all this half into p into what, dv by dt, all this, all formulas just make what, half of. Why this, that I have explained there already, okay. So this was your complete work, energy, power chapter revision, right? Now three things we have, work, energy and what, power. Work we can have variable force or what, constant force, depends, right? Or they can ask in terms of like vector form, right? Okay. Then energy we have three types, kinetic, potential and what, spring energy in this topic, right? Okay. Kinetic energy generally they relate with what, work energy theorem, right? Now work energy theorem, the work done is simply equal to what, change in kinetic energy. This could be also potential energy also, okay, but generally they ask this question in terms of what, kinetic energy alone. Okay, potential energy main formula this one, that here main concept is what, equilibrium of the system, right? Now okay, equilibrium we have three types, and how you know, by knowing the differentiations, right? Now okay, then spring energy you have seen, okay, here two type of question, point masses or what, regular bodies. Point masses means general like mgh, and regular bodies means you have to talk always about what, center of mass, the change in height of the center of mass, always you have to talk in the formula. Okay, spring energy means what, you know, half kx square. Again here two type of questions we have, mainly the maximum compression or expansion they ask, we have to use energy concept. They ask compression under equilibrium, then you have to use what, force constant, force concept, sorry. Yes, okay. Then at the last point was about what, power. Power is simply equal to what, rate of doing work or rate of change of what, energy, correct? Or you can write force into velocity. Then this for pipe, at least 5 times this question was asked about pipe, okay, in our exam. So pipe I wrote all possible formulas. There are even some other formats also there that I taught you during lecture time, okay. So this is a complete revision. If you have any doubt, any confusion, please put your comment. Thank you so much.